Alright, welcome back from break. It's been a while since I've done a video, and we are going to go to a new chapter. We're going on to chapter 4, and our big topic on chapter 4 is integers. Okay, we are going to do chapter 4.1, and we are going to write about integers that represent situations. All right. So first question would be, what are integers and how do they compare to the numbers that we used before? And the integers are a set of numbers, and we were kind of talking about a previous set of numbers that we call the whole numbers. And the whole numbers kind of go like this. Now I use that squiggly little symbol when I'm doing whole numbers. Hang on, let me see if I can fix a little bit of that, make it a little bit clearer. That looks a little better. I use my little squiggly number set, and whole number set starts at 0, and it goes 0, 1, 2, 3, 4, and it goes on infinitely in that direction, all the way up till forever, right? Our integer set is a little bit different. It's the whole numbers, and it includes their opposites as well. So we would write the whole number, or the integer set, like this. We would start at -4, go to -3, -2, -1, 0, 1, 2, 3, 4. Oops, and I forgot my little dots in this direction. And it represents a set that goes to infinity in both directions, starting at 0. So we're going to be including these negative numbers. And these negative numbers are very important when we're talking about distance and when we are comparing things to other things. And we're going to be taking some situations where we would actually use negative numbers today and turning them into how to write them. I don't think this section is particularly difficult, and so we're going to do a couple sections with it today. When we're looking at when we're looking at integers and we're kind of doing a lot of these, the number line is going to be kind of king of everything that we're doing. And if you recall, those number lines are just simple things that we build like this. And we typically go 0, 1, 2, 3, -1, -2, -3. Now, you guys know that not every number line looks exactly like this. I can put a number line anywhere along my sets. I can build a little mini number line that goes like this. 100. 100 and, oops, that's supposed to be 101, 102, 99, 98. I can also build a little number line that would go like this. -97, -96, -98. The only key to my number line that stays consistent no matter where I'm at is if I go this direction, it gets smaller. And if I go this direction, it gets bigger. That's true for this number line. Going this way from 0 to 1 gets bigger. It's true for here, going from 100 to 101 makes it bigger. And going from -97 to -96 is getting bigger, as though, even though that can be a little bit weird sounding, right? So the question becomes, when we're comparing things without the negatives, how do we figure out what is bigger? So, for example, our little example here says this. It says, Michelle lives in Salt Lake City, Utah. In school, she learned that Salt Lake City is 4,300 feet above sea level. Michelle is going on a vacation with her family to Death Valley in California. So let's write down what we know. In Salt Lake City, the elevation is 4,300 feet above sea level. Her mom told her that Death Valley is the lowest land in North America, and it is 282 feet below sea level. So at Death Valley, it's 282 feet below sea level. All right. So how could Michelle represent the locations of Salt Lake City and Death Valley with respect to sea level using the integers that we've been talking about? So it kind of goes like this. Because 4,300 feet is above sea level, we can look at it as an above zero number. So we can simply keep that the same and write it as 4,300 feet. Our 282 feet below sea level, though, technically is below zero because zero would be our sea level value. So we're going to write 282 feet as negative 282 feet. Because if I were to graph this on like maybe an up and down number line, like I would use if I was going to graph elevation, and I had my zero here, my Salt Lake City is going to be all the way up here at 4,300. And my below sea level is going to be right here below sea level at negative 282. It wouldn't be fair to call this positive 282 because I know that it's below the actual sea level, okay? So let's look at a couple of examples on how we can write these. Now I know a lot of this is pretty easy and refreshing, but it's important to talk about exactly how we write it and exactly the process that we go to use it. So we're going to, in this section, kind of answer two different kinds of problems. Let's look at, first, we're going to write it as an integer. So, example 1. Oh, I forgot to change colors. I'm trying to work on that. It's my goal for myself. I'll just make a little, now it looks like it's on fire. Hey, that works. Okay, example 1 goes like this. An increase of $200. Okay, so that means that I'm going to the right and I'm going to stay positive. So I would just write this as 200. Okay. Let's look at Joe was paid $15, then bought a fancy dessert for $20. How would we represent this as a total? And I can write this as two integers and an operation. So if I say he was paid $15, that is positive. Then bought a fancy dessert for $20. Then I can say minus 20. Now, a lot of times this minusing comes in money and it comes in distances. So expect to see money and distances in a lot of these problems. Okay, let's look at a couple more. If you feel like you get it, go on. Example 3. If I was going to write this as a sea level, as an integer, I could write it 50 feet below sea level. And I'm going to write that as minus 50 feet. Because compared to negative, it's going to be, compared to 0, it's going to be down and it's going to be negative. Example 4. Say we're at $10,000 feet elevation, and we go down 3,000. We can write that as a integer expression. We can write 10,000 minus 3,000. Oh, and I should keep my units on there as well. Okay? Now, that's pretty much how this is going to go. And it should be fairly easy to do. If you have any questions, ask. And good luck.